Hello and welcome to this session, part of the bSDD International Summit, Singapore 2025. Thank you for joining. My name is Laura and I will be your moderator today. Today's session is titled Advancing BIM Data Quality with Open Standards. The speakers for this session are shown on the screen. This session is scheduled to last 90 minutes, including time for questions at the end. The session is being recorded and will be made available in the replay section of this event as soon as possible. Before I hand over to the speakers, I would like to remind you that this is an hybrid event. For online attendee, your microphone will remain muted for the duration of this session. If you wish to make a comment or ask a question, please use the chat box in the control panel. For the attendees here in the room, please keep the background noise to a minimum. And if you wish to make a comment or ask a question, please raise your hand and use a microphone. I would also like to bring to your attention that bSMART is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent, and standards that developed do not favor any particular provider and are open, non-binding, and accessible to all. Please take note of our antitrust code of conduct, and I would like to hand over to Benjamin.
Hi, it's nice to see that so many of you made it here. I was a little bit scared to stand here having this presentation in front of an empty room, but it seems like this seems to be the opposite almost. I'd like to start to ask you a question. Which one of these two do you relate the most to? If you relate to the person on the right, buried in data and all that comes with what a wonder that the data is, or do you feel like the left one, that you have full control of it instead? And which one would you prefer to be? Would you prefer to be the master of the data, or do you prefer to be mastered by the data? Today, we are standing at this crossroad where we can make this active choice, actually. And I am going to show you why the path of digital transformation fueled by open standards like Open BIM, bSMART, A-Team is not only an option, it's actually a necessity. We'll explore some challenges of fragmented data and the power of open standards and the tangible benefits that comes with unified collaboration. But first of all, my name is Benjamin Sjölander. Unfortunately, this is not my house, but it's from my hometown at least, so I get to enjoy the view sometime. I am the standardization manager at A-Team International with a background in BIM and data management. I want to show you my whole list of certifications. You're quite familiar with how those goes. But my experience has given me quite a unique insight in the challenges that we are facing in our industries, both on the digital side as well as on the construction side in the real world. Now, I'm going to spend a couple of minutes, since I know that not all of you are fully aware of what and who A-Team is and what we do. Some of you may know us, but this is so everybody has the same understanding. The seed that has grown into what A-Team is today was planted in '91. And this was a time where technical products, data, through the whole supply chain was suffering heavily from managing data, different formats, structures, and terminology. Does it sound familiar to any of you today in your fields? Well, this was the status quo back in the days. And everybody was reinventing the wheel over and over again. But the Dutch Electrical Installers and Wholesalers Association came together, the UNITO, and wanted something else. And that's when A-Team was started. They realized that talking about the same type of product in different ways is not the optimal way. It's the root cause for issues and miscommunications that only leads to increased costs. So they decided that we need to come together. We need to start talking about the same product, using the same type of language. And standardizing the data, meaning that everybody speaks the same language. This improved the data quality, streamlined communication, and saved everyone a lot of time and a lot of effort. That's the power of shared standards. But they didn't stop there. They realized that instead of using text fields that can easily be mistranslated, misunderstood, and changed down the line, using codes instead of text strings opened up borders. Now, opening up for new markets, where every single market are responsible for their own language, making sure that we are talking about the same product every time. That sounds quite familiar to things we have heard here at the buildingSMART Summit so far as well, for the BIM world. A-Team grew, or more or less it started to explode. The adoption grew, the support grew increasingly, and in 2008, what had started in the Netherlands as a regional standard proved to be an international one instead. And A-Team International was founded in 2008 with a clear governance built on markets' demands and as an open non-profit standard. We are built on these 4 pillars: collaboration, transparency, sharing, and empowerment. 2017, we partnered up with buildingSMART. We saw that we are experiencing the same type of issues in 2 different fields, but we are interconnected in some way anyway. By bridging or starting to build this bridge between these 2 standards, we can find new enhanced data flows and drive efficiency in construction throughout the whole supply chain, starting from the first line that is drawn to the last brick that is laying in the building. So it's now about making digital workflows. And that digital workflow was actually enabled in 2019 when A-Team was published for the first time in the bSDD. This created a long-needed bridge between the digital product and the real-world product. This ensures for consistent data for construction and will be a game changer for BIM. A-Team is actually one of the most used or searched in the bSDD, according to the statistics that I've read. Four years later, by market demands, A-Team modeling classification standard was included. We define an object not only by data, but also by some standardized, the basic geometric that is needed. This is something that the real world has in common with the digital world as well. We need some basic understanding of what the geometry actually is. And this merges the real world products with the BIM geometry. And today, A-Team is global. We have thousands of classes, dozens of country members, used worldwide, and we have a fast-growing user community as well. We are backed and supported by over 50 trade and industry associations. Oh, a little closer. That's better? Great. And when A-Team is used in BIM as well, through the IFC and the bSDD, that's when we can create something powerful and make something powerful happen. But now, with that foundation laid on what A-Team is, the crash course, you all get a certificate later on that one. Let's talk about BIM. Because with BIM, everything just works all the time. That's right. That's it for me. Thank you. Well, that's not really the case. I wish I can come back in a couple of years and tell you this and end the presentation at that slide. But the reality is a little bit different. It almost works. It's such a powerful tool. If we only can start to learn using it in a more unified way. But today, the reality is that we have data errors, multiple file formats, software ecosystem, manual work, rework, and a lot of language barriers, both inside the systems and across the borders. And these challenges have clear consequences throughout the whole project. And even though with all these challenges, BIM is proving to be increased efficiency, and it helps us avoiding clashes and improve the overall quality, actually, even with all the consequences it actually have. But according to a study I read from a large software supplier, software I know that a lot of you are using in your daily work, concluded that 95% of all projects are suffering from data issues. That's a lot that are experiencing issues. A lot of effort, time that could be used for something else. Luckily, the future is standardized. We all are here for one thing, and that is to collaborate, trying to find a unified way forward, and to increase those 5% to a much larger number in the future. Just imagine what that will do for the whole industry, not only the BIM industry, but the whole construction industry as a whole. So today, the BIM industry juggles with files between multiple parties, between architects, map engineers, suppliers, contractors, and facility managers, to mention a few. Different tools are used. Naming conventions are different. Multiple languages could also be included. And you need something that holds things together, that makes everything more understandable. And that is by using the bSDD. That enables people to early classify a product or object and making it understandable down the road when you're handing over the project. And with the bSDD as the dictionary, IFC can act as a universal translator between different software ecosystems. I won't say file format because I think Arthur will throw something at me if I do that. But this leads to fewer errors, reworks, improved communication, and ultimately a more efficient and successful project. It allows you to share geometry. It allows you to share data, high quality data connected to the real world products. It's a keystone in sharing information in BIM. And BIM without information is not really BIM, is it? That's a part that is usually missing in a BIM project, the information part. And by using IFC, bSDD, and A-Team, you have all the keys to connect it all together. Digital objects can be referenced to real products using the same foundation when it comes to geometry parameters, the same classified product data features and attributes, and connecting it to the real world product, making it possible for the contractors to easily find new products without having to go back inside to the BIM project, exchange a lot of objects. You use the same type of basic data in a structured and standardized way. So open standards, free to use, connecting the whole chain from digital to real world with consistent quality data. That is the future that we are heading towards. coming together, collaborating throughout the whole chain, not only the digital, but combining the digital supply chain with the real world product supply chain as well. By doing so, we can stop being limited by borders, start collaborating across borders more efficiently. And this collaborative open approach sets a stage for long-term success, especially in large diverse markets, such as Asia for once. And it helps us to stop wasting time and money by collaboration without any borders. And without borders, the world opens up for us. We can start working together universally across the globe. Shared information and data can flow seamlessly, automate time-demanding tasks with high-quality data. And this is a proved concept that a collaborative approach by embracing open standards opens up opportunities for companies to scale and grow. And in the beginning, ask this question: who will be the master? Well, actually, I have more of a request. Let's take control instead of the data. And by doing that, we will also become the masters of the future instead. Make an active decision to move forward in the right direction. So let's work for a better tomorrow. And most importantly, let's do it together. Thank you. Any questions? Great. Everybody passed the certification then.
Okay, hi everyone. So I hope that through today's presentation, so I can share with you all the value of bSDD and IDS. So here as a project member. So first is project leader, Dr. Yoshinobu Adachi. So Dr. Adachi has been involved in the development of IFC for many years. So, and his achievement are so great that one of the fathers of IFC 2.3. So his name is listed next to Dr. Thomas Liebig, so in the IFC schema. So he is currently a fellow of buildingSMART International, so where he contributed to the development of the industry. So next, Mr. Yachi, so as domain advisor, Mr. Yachi is an expert on building equipment, and he's contributed to the development of the BIM library for today's presentation. So finally, I'm Yoshiyuki Miyauchi. So as a technical lead for this project, so I am responsible for the implementation of bSDD and IDS. So also I'm working for a Japanese tech startup company as Chief Technical Officer and bSMART Japan. Okay, so here is a description of the target audience. So for today's presentation, so first, Open BIM is for all construction professionals, so who want to improve the productivity and the sustainability of your business. Secondly, so it's also intended for those of you who wish to implement bSDD and IDS in your projects. So finally, there are those who wish to understand bSDD and IDS. Okay, so let me explain the purpose of my presentation. So through this presentation, we hope to explain bSDD and IDS so as simply as possible and increase the number of people who understand bSDD and IDS. So I would also like to help everyone understand how bSDD and IDS were implemented your project. So not only how to create bSDD and IDS, but also how to develop use cases bSDD and IDS. Okay, so the next section describes the key points of our presentation. So you will all know the basics of bSDD and IDS and how to use bSDD and IDS in use case. So software that can be used with bSDD and IDS will also be presented. Okay, so now let me introduce you to bSDD and IDS. bSDD is a set of definition of classification system codes, properties, and property sets to be referenced by OIR, AIR, EIR, and PIR. So bSDD can store and associate information on various construction types. If you have contracted a construction project, you can refer to the bSDD to check the information requirements to the included in the BIM data or IOC. Various languages and ontology information uploaded to the current bSDD. So since bSDD is free of charge and its API is open to the public, it does not hinder third-party software development. So of course, once again, bSDD's API contributed greatly to the success of our project. So as Mr. Adu, so the presentation opening plenary, so showed the access to bSDD is quite vast and many projects are in the process of implemented bSDD. So let's take a look at the contents of bSDD. So for those new to bSDD, so we have prepared a study dictionary. So the name of the fruits and vegetables. So yes, so a dictionary on apples you can check. So if you would like, you can check it on your laptop as well. So however, the current bSDD website so is not suitable for viewing on a smartphone. So viewing on a laptop is recommended. So now let's look at the dictionary of apples. Okay, first of all, apples have many different varieties all over the world. So various varieties exist, so such as Granny Smith and Boss Coupe. In addition, so an apple is first composed of peel, cheese, flesh, and wine. So the performance of each variety is, of course, different. So, but it can be expressed as a set of properties. The advantage of bSDD is to express the vocabulary related to the word apple. So the information held by the vocabulary can be represented as a project set, so which can be tied to the vocabulary and visualized. So there are various types of class-to-class relationships and class-to-property relationships. So example, parent-child relationships and compositional relationships. The material that makes up an apple is composed of a variety of materials. So starting with water, vitamin C material composition can be expressed in bSDD. Next, let's focus to the vocabulary that makes up the apple. So apples are composed of peel and flesh, right? The peel and the flesh of an apple have various property sets like IOC. These property sets of the peel are color and pesticides. So this is just an example. Yeah. The most significant advantage of bSDD is that it can digitally represented what meaning or object an apple is composed of and what property sets it has. The bSDD can also represent linkages to dictionary as the Apple dictionary. So a typical example is which class in IFC, for example, can reproduce an object called Apple. If you are a Granny Smith farmer, for example, you can refer to the bSDD of the apple to set what performance the Granny Smith should possess and produce apples that meet the requirement. The next section describes IDS. So what can IDS help with? So in a nutshell, an IDS is a standard for describing information requirements. So IDS make a significant contribution to IRC compliance checks. In addition, IDS can be very useful in making IRC richer. IDS consists of 6 facets. So it can be seen that IDS is useful not just for property checking, but also for checking the structure, classification, and the materials of IFC. IDS can be created on its own. However, with bSDD, IDS can be made faster and more accurate. IDS is closely linked to the bSDD. We often see use cases where only IDS is utilized, but IDS should be operated together with bSDD. Okay, so from here, Dr. Adachi will explain our Japan initiatives.
Good afternoon, everyone. I'm Yoshinobu Adachi, and I'd like to touch on a little bit about background, why we are doing this kind of mapping from, we are talking about library template, traditional old style library template to bSDD. But this story is very similar to Benjamin's E-Team's trial. I mean, so I'm feeling that we are not alone and we are heading the same directions. And the audience who are very interesting or who has your own library template, library definitions, probably this presentation will help a little bit about your effort to much more digitalized and efficient way of open BIM workflow. And so this chart is the left-hand side. So far, library template is kind of represented by big table, property name, data type, and description or something. So such kind of spreadsheet is printed on the paper, and the engineers are reading. So that's not good. So we need to move to right-hand side. So our the basic concept is mapping your own old style spreadsheet library template to bSDD. And once you got bSDD library template, last half of our presentation, we can have a lot of fringe benefit from bSDD contents. And this is the basic concept of library template and library relationships. When we talk about a library template, the library template is just, it's kind of schema of a property set. It's not a library itself. Based on a library template, normally we will make some generic library and the product library. So the difference between generic and the product library is in Japan, we have some definitions. Before selecting it's a concrete product, there is a need to handle a little bit abstract object. So we are calling that kind of non-product object as a generic object. So that's why we are calling the two types of library, the generic and the product library. The normally product library, its content is produced by manufacturer. So product library, its contents has it's a product name, product numbers, or manufacturer specification or something. So, but generic libraries, they have not such it's a detail of information. So we are talking about today, we are talking about a library template mapping to a bSDD. And this is a very typical old style spreadsheet library template in Japan. So we have a E-Team like standard provider in the MEP it's manufacturing industry. We call BLCJ, BIM Library Consortium Japan. The BSJ, Japan chapter, is collaborating with BLCJ to conduct the mapping from their old style library template to bSDD. And now I'd like to introduce Mr. Yachi as inside persons of BLCJ, who is in charge of the definitions of MEP part of library template. So please give us a few words.
Good afternoon, everyone. I'm Yachi. I explain this slide. I explain this slide so shortly. I am a member of the buildingSMART Japan. I'm a member of MVP committee, but also, I am a member of BIM Library Consortium Japan member. So the BLCA, the Japanese BIM Library Maintenance Organization, use Excel like this as a library template. However, this Excel is the organization's own style, and this Excel is only approach for the organizing information and not for the information delivery. And our jobs engineer is to create a design that will improve the environment. Designing one design is not our goal. In order to create a better and more eco-friendly design, I would like to use IDS and data to work more and more efficiently. That's my explain. So, understand, please.
Thank you. So the story is we have this kind of old style library template in different industry. So, and the idea is using bSDD is very open workflow, good approach. So that is the basic idea to share with you today. And so this kind of the comparisons of good things and the bad things. The left-hand side, this is kind of spreadsheet old style, and we are going to right-hand side by using bSDD and IDS. And in part of my last slide, this is the important things of a streamline. If you, from left-hand side, you have old style information representations, and so there is the process to map the old style spreadsheet to bSDD. So that's kind of our experience should be shared in this kind of summit. And so eTeam was one of its very advanced things, and our experience might be shared in the coming summit or something. So this is just a starting point. So once we mapped the old style library template into a bSDD, afterwards the Yoshiyuki will show demonstrations of semi-automatic generations of IDS from bSDD content. So this is very good fringe benefit of bSDD utilizations. bSDD can produce, I mean, it's using bSDD information, so you can generate your own information requirements as IDS. But once you get IDS, you can utilize some BIM native modeling along with IDS contents. And of course, IDS can be utilized to validations of exported IFC. So we are now testing this kind of streamlined and with BLCJ organizations. And the next time, probably we will share much more. It's a good result and experience how to work. So this is the basic idea of what we are doing now. So afterwards, so Yoshiyuki will show much more concrete demonstrations of how bSDD IDS works.
Okay, so from here, I will explain our specific approach for each steps. So step 1, so bSDD was adapted as a library template. So under Excel was converted to bSDD data to make the data suitable for information distributions. The converted bSDD was already being uploaded to the production environment. Okay, step 2. So IDS can be created from BIM library uploaded to bSDD. So as a single source of truth, it extracts information requirements from the information requirements raised in the bSDD that are suitable for the project. So requirement. The advantage of this approach is that the information requirements can be used to create IDS more quickly and accurately than creating IDS from scratch. So even if information requirements can be prepared, they are meaningless. So if they cannot be loaded into a BIM authoring tool. So on the other hand, if the information requirements are properly prepared, importing the information into the BIM authoring, BIM data or IOC is now instantaneous. So with plugin for BIM authoring tool, you can quickly create BIM data or IOC that meets the information requirements. Okay, final step. Information requirements are used to check the accuracy of the IOC. You can check that the information requirements are assigned instead. So IDS can automatically check that the IOC has been created properly. So the flow from step 1 to step 4 can be horizontally expanded in your countries. So of course, that contents of the library will differ from country to country. So, but I'm sure that the same approach as our efforts in how to use bSDD and IDS, so will be adapted in the countries. So the efforts of the use case will also be explained. So the accuracy of the information given is now 100% perfect thanks to bSDD and IDS. So the time required for information assignment has has reduced by 80%. So efficiency of information checking reduced by 90%. So with bSDD and IDS, so the productivity and the sustainability of BIM data or IOC has increased significantly. So it's a true game changer. So this brings significant benefits to both clients and contractors. Okay, recap use case. Okay, bSDD is an ideal information delivery template for BIM libraries. So IDS is a good approach for importing information requirements into BIM data or IOC accurately and quickly. So automatic checking of BIM data or IOC by IDS is important for proper IOC data delivery. So clients and contractor trust will be ensured with bSDD and IDS. Okay, as a reference for use case, so development, we will conclude this section with an example of a similar approach we have adopted and developed for IFC SG. So we would like to actively expand this, our use case approach horizontally, not only in Japan, but also in other countries. We have prepared explain a video which we will now play. So.
Step 1. Selecting IFCSG information requirements. In this case, we adopted the IFCSG Excel mapping file published by CornetX. Step 2. Creating IFCSG bSDD. The solution we are using is OpenAEC. With OpenAEC, you can create a bSDD and define custom class and property. By preparing a bSDD, distributing the information that should be attached to BIM data becomes easier. The benefits of bSDD are not only information delivery, but also by using OpenAEC for bSDD, it becomes possible to directly input bSDD information into BIM data. We create a bSDD for two classes, door and wall, as test cases. After creating the class and property, it is necessary to link the property to the class. Using OpenAEC, you can link the class and property in the bSDD you create not only to those in your organization's dictionary, but also to the class and property in publicly available other bSDD dictionaries. You can confirm that the property defined within the project is linked to the class. The bSDD that you created can be published online by uploading it to the bSDD management site. The uploaded bSDD can be viewed via bSDD webpage. Step 3. Creating IDs using bSDD. The solution to be used is OpenAEC. With OpenAEC, you can create IDs and define information requirements tailored to each project's use case. In ISO 19650, IDs corresponds to PIR, IR, and AIR. With IDs, you can clearly define both the applicability and requirements for each specification. With OpenIX functionality, you can search for the information requirements necessary for your project based on the information provided in the published bSDD and smoothly set up the IDs requirements. It is possible to search for bSDD defined within your organization or published, and add classification, property, and material. Select the property to add. The property selected from the bSDD was added all at once. For this case, we created requirements for door and wall. Step 4. IFC production based on IFCSG. We use OpenAEC for bSDD and desktop. We adopt Revit as BIM authoring tool and perform modeling with it. We assign IFCSG properties using OpenAEC for bSDD. First, we configure the bSDD dictionary to be used in the project. Next, select the objects to which property information will be assigned. In addition to manual selection, batch selection by category is also available. A tree view of the classes registered in the bSDD is displayed on the left side. By utilizing the information from the bSDD, shared parameter file can be automatically generated. Parameter files can be opened at any time. Next, configure the attributes of the IFC classes. The property set and property list can be obtained, and the property value is automatically obtained from allowed values in bSDD, and the choices are displayed. Within the tree view, you can display the URL for the selected item, allowing you to confirm the bSDD's content in your browser. Save the shared parameter file. After saving, you can confirm that the information has been successfully stored in the file. You can confirm that the property set file has been automatically generated. When you add a property, you can confirm that the custom property is successfully applied to the door. Export setting automatically generates the settings for IFC property generation. The IFC export configuration JSON is auto-generated. Export the IFC data. In the output settings, set the configuration file generated earlier and specify the IFC version. When you check the Property Sets tab, you'll see that the property set file is correctly set and classification has been applied. By using OpenAEC for bSDD, the tedious process of generating setting files is fully automated. However, rapid exported IFC classification settings don't comply with bSDD regulations. The process is simple. Just select and load the IFC data you want to modify, and you can adjust the IFC classification within the IFC. Confirm IFCSG in OpenAEC for desktop. When you import the created IFC into OpenAEC for desktop, you can check its hierarchy, geometry, and classification. When viewing the classification, you can confirm that the bSDD information configured using OpenAEC for bSDD has been applied. You can confirm more information about bSDD. Classification is displayed in a hierarchical structure, and under the dictionary, the classifications for door and wall can be confirmed. Step 5. Automation review of IFCSG data. The solution for reviewing IFC data is OpenAEC. On the review screen, you can view a 3D display of the target BIM data along with the IDS file. Press the Run button to start the review. Execution reveals pass counts for each specification and requirement. The results of the review for each specification are also displayed, allowing you to check in detail whether the IFC data meets your information requirements. Step 6. Data operations. The solution for data operation is OpenAEC. With OpenAEC, you can connect the data you want to manage and operate to a CDE, such as ACC, enabling centralized management. Additionally, IFC data can be delivered to a common data environment shared with your customers. It can be confirmed that it has been successfully uploaded to the CDE service.
Okay, so finish. That's all our project presentation. So thank you for listening. So any questions? So so I guess my presentation time was too long, or if you have any questions, so please let me know after this session or summit dinner. Okay.
Okay, for this third and last presentation of this session, we'll start with a little story, or more a situation. So presume I'm an architect and for the first time, I created a BIM model. I'm very proud of it. I worked all night to finish it. And I'm ready to share it with the structural engineer who will look at the building and give advice on the structure itself. So I'm ready to share it. But I'm not very sure that after a long night of work that the data is really as it should be. So I'll want to do a final check on the data structure, the content, and so on. So I looked on the buildingSMART website and I found a very interesting document. It's the BIM Basic Information Delivery Manual. And it has some nice topics on which I could check my BIM model. So I have the BIM model of the project, 2 towers, some apartments in it. I received also a model from the surroundings, from the site itself. And I use Conic. Conic is a BIM platform. It's used for BIM modeling and for editing the geometry and the data. So as I'm a bit tired, I asked my colleague Jakob to check the model on Conic and to see if there are some changes needed or not.
Okay, thank you, Dieter. So I will indeed use Conic to check these 2 models on the different requirements that are outlined here in this manual. So there's a bunch of points that we're going to go through, and I'm just going to run through them one by one using the Conic platform. So the first one here at the top right is just the file name. You want to make sure that their different models are named correctly according to a certain structure. So that's an easy one. We can just simply change the name of my different models. So let's use some convention, maybe a code, the project name, and maybe the discipline as well. So let's say architectural. And the second one is the landscape model. So let's give it this name. So that was quite easy, right? Let's go to the next point, the local position and orientation. So you want to make sure that the local position of the building is coordinated and close to the origin. Let me open the models to show how this would work in Conic. I'm going to use the Conic application for this. So I'm now opening these 2 models in a single environment. And we can right away see that there's already something wrong with the location of these 2 models. Apparently, these 2 models are far away from each other. So the 2 models came from different sources, different creators, and for some reason, one of the creators that used the wrong coordinate or wrong location. We can luckily rectify this. So we can see here that this architectural model is around 6 kilometers away from the origin, whereas the other one is right around the origin. So we will move the architectural model closer to the landscape model. This will just be a first pass, like a rough reposition to make sure both models are close to each other so we can visualize them and interact with them. But you can see they're clearly not still in the right location. there's this cutout available for the buildings, but the buildings are floating over here. We can luckily also rectify this in Conic. We can use this, do this using coordinates, or we can use reference geometry to rectify this. Luckily, in this case, there's already some sort of origin cube defined in this model, as is also actually defined here in this requirement as a little tip. You should use this kind of reference cube. Actually, my other model also has a reference cube. So I just know if these two cubes are nicely aligned, then I know my models are correctly positioned with respect to each other. So let me select the entire architectural model. I will use this browse panel for this. And let me align this model. So I'm again using these reference cubes to align the models. And now we can clearly see that the model is correctly aligned. This is not a temporary thing. It's actually a modification of the model. So if I take this model out of Conic again, the location will actually be correct for the rest of the duration of the project. Basically, the Conic platform, the entire data structure of Conic is based on IFC, the IFC schema. So we use the same terminology, the same structure, and that also includes things like spatial locations. So for instance, if I take a look at my locations in this project, I can see that I have a site with, in this case, 2 buildings, within each building, some floors. And this site actually also has some properties such as longitude, latitude, and so on. So you can change the coordinates of this site, of this building, if this would be incorrect. Next point in this IDM is building, story, and naming. So as I just said, we're using the same IFC structure. So buildings and stories are also defined in the same way as in the IFC schema. We can take these buildings and stories from the IFC file. We can modify them where necessary. For instance, I can see here that I'm using a certain naming conventions for all the floor, but the top floor here, the roof, doesn't have this little code in front of it. So maybe let me just change the name of it. And I'll add this 08 prefix to it. Let's also check whether all of the objects in my model are actually on the correct floors, in the correct spatial location. I will again use this browse panel here on the left-hand side. It's basically configurable based on all kinds of, or any data that's in your model. So you could say, okay, I'm interested in only the buildings and the stories and the objects within these buildings and stories. So I can see I have the site, I have 2 buildings, some objects that are not part of the building, and then within each building, some floors. And I'll just select each floor and do a quick visual check whether all these objects are indeed on the correct floor. So this looks good. Looks like there is something wrong here. So we're on the 7th floor, but actually I can see a bunch of doors selected here, which should be on the ground floor. So let me briefly select these doors here, check their properties, and I will indeed see that these doors are located on the 7th floor, which is obviously incorrect. So we can also rectify this. I'll just change the floor here to ground floor. So if I now just go back, I should be able to do a quick check again. And normally everything should now be properly associated to the correct floor. So that's done. Next point is the correct use of entities. So using the correct IFC class for the objects in your project. So as I mentioned, the entire Conic data structure is based on IFC. So there's a one-on-one translation. There's barely a translation even. It's just a one-on-one mapping between Conic classes and IFC classes. And again, I'm going to use the browse panel here to quickly check on the different types. So I can see I have beams, I have doors, floor terminals, and so on, furniture, railings, roofs. Actually, I've also split up these different groupings here. So per material as well. So we have 3 types or 3 materials within the beams: cladding, foundations, concrete, and reinforced concrete. And actually, let me just isolate these beams for a second, so it's a bit more clear. We can see here that, for example, these cladding aluminium objects, which are classified as beams, they're not really beams, right? They should be more like a covering, for instance, an IFC covering. So we can rectify this as well. Let's reclassify these objects to covering. So all the possible classes are available here. Let me just search for covering here and edit their class. Same goes for these concrete beams here. They're at the bottom floor. Actually, we know they're not beams, they're actually foundations or footings. So we can also rectify this, give them the correct class. Now, something we're working on right now is the automatic classification of objects based on geometry and context. This is still in development, but I'm still going to show you something anyway. It was requested by Leon. Still in development, so it might not work, but we'll see what comes out of it. So basically, the idea is that you can select any object. Let's say I select this, what looks like a staircase here. But I can see in its properties, it's currently classified as a building element proxy, kind of a generic class if we don't know what something is. Again, I can reclassify this. Let me make sure I have the correct one here. I can reclassify this either manually, or I can choose Conic to find the class for me if I'm not sure what it is. So let me click this button here, and it found that the top hit is a stair. So according to our machine learning algorithm, the most likely class for this object, based on its geometry, based on its context, and based on the data that's already assigned to the object, is probably a stair. So I'll just accept this and change the class to the stair. This works for any kind of geometry. So for instance, let me try this window here. This is already a window, but let me just do it anyway. And it says indeed, top hit is a window. That's already the current class, so I don't need to do anything. This will be available in one of the next releases, so something to look forward to. Thanks. All right, let me go to the next point here, which is the structure and naming. So we want to make sure all of the objects are named correctly according to a certain structure, and the IFC types and object types are also used correctly. So again, I'm going to change this configuration to make sure I have this one applied. I can see all the different objects in my model grouped by name. For instance, these exterior doors here. And I've also grouped them within each naming group by type as well. So actually, let me briefly show you how this grouping works. So you can group and filter on any kind of data that's in your model. In this case, I have two grouping levels, one by name, one by type. And in this case, these 4 doors that I have selected here actually don't have a type assigned. So they came in the IFC file without an IFC type. Luckily, we already have some types for exterior doors defined in this project. So I can apply this type to these objects. So let's apply the exterior door type, which was already defined in the project. Currently, these types are data only. We're also working on a sort of geometry and data integration so that you can have library of types with geometric representations and data representations as well. Okay, next one is an interesting one, the classification system. So it's possible to bring in classification systems in Conic. Let me again use the browse panel here to group by classifications or by codes. In this case, this model already has objects classified according to, in this case, the NRM. So NRM is the new rules of measurement, which is a British standard, often used for quantity takeoffs, for quantification of materials. Great thing about this NRM system is that it comes with measurement definitions per code. So for example, a concrete floor slab should be measured in net volume, for instance. But we can actually bring in different systems within Conic depending on region or use case. So in this case, this NRM system was actually already inside the original IFC file. So I can say, okay, I'm interested in maybe the upper floors, which is part of the superstructure. So we can quickly see here the different objects that have these codes assigned. But what if we want to use other classification systems within this project? That's where bSDD comes in. So we can actually connect bSDD with our project. So let me open the browser here. So this is, again, I'm back at my project dashboard where I have my two models. At the top here, you can see this libraries section where we can import libraries for things like codification systems, materials, properties, and so on. As I mentioned, we already have this NRM system in this project, but we can also add other systems. So let me create a new library here. I can create one from scratch, import a CSV or Excel file, or I can use the bSDD API to bring in a system that's hosted by bSDD. So here you can, for instance, see the possible systems we can bring in. Let's use ATEM. It was so nicely introduced by Benjamin earlier today. I'll give it a custom name as well, ATEM, and I'll just create this. Now this ATEM library is brought into my project, and I should be able to use it within my models. So if I go back to my model, and let's say I want to classify the toilets according to this ATEM system, I should be able to now add this code here. So I will add a new code to these toilets. Okay, the ATEM system is not yet loaded. Sometimes it takes a second. But the idea is that here you would see the ATEM library as well available, and you're able to assign certain codes to these toilets. Next point is the materialization. So I will check if all the objects have correct material assigned or have überhaupt a material assigned. So objects with correct materialization. Again, we can cycle through the different materials and see whether the objects that have this material actually, if it makes sense. Now, I think in this model, everything is already correctly assigned. If something is incorrectly assigned, again, you can change the material. We can interact with the actual material definitions. So there's, on the one hand, material allocation or material assignments to objects, but there's also the material definitions, which are stored in a library, a project library, with which you can interact. So in this case, let me load the materials here. So all the materials used in this project are defined here, and we can actually interact with these materials, change their color, description, and so on, but also use assign material properties and property sets to these materials. So this is all again based on the IFC schema. So there should be no translation issues when bringing in IFCs or exporting IFCs back out. I think we're almost through to the end. So there's one more about duplicates and intersections. So you want to avoid that there are, of course, duplicate objects in your model or objects overlapping, which physically shouldn't be possible. So Conic can also be used to do checks about that. So let's keep it simple and just focus on the walls for a minute. So I'm just going to isolate the walls. I'm just going to do a clash detection on all the walls in this model. So we'll select all the walls and clash them. I'll only search for hard clashes, so I'm not looking for tolerances or anything. I'll apply this, and it will do a clash detection in the background. It's still going right now, but I can still interact with the model while this is going. Okay, it looks like there are two clashes between the walls here in this building. Let me click on this first one to see where it is. So it looks like indeed there are two walls overlapping. So this wall here and the other wall here. Now the great thing is that you can resolve this clash directly in Conic. So Conic is not just a data management platform, it's also a modeling application. So I can actually say, let's subtract this volume from the other volume, and the geometry will be adapted. Let's also check the other clash. Yeah, looks like it's the same issue. Let me just push-pull this. Like this to resolve this clash. Okay, and then there's a few more points about property values and property definitions, such as commonly used properties like load bearing as external and fire rating. Again, I can use this browse panel for this. So I'll do a quick check for this first one for load bearing. And I can see I currently have, let me make sure I have the entire model again in my view. I have some objects which have load bearing value false, some with true and some with none, which means either the property is not assigned to the object or the property is assigned but it's not filled in. So let's start with this these load bearing object, for instance. Maybe I can see here the objects that don't have a load bearing property assigned. Let's take a look at these slabs, for instance. So these balcony slabs apparently are not load bearing, or there's no information about it. So I will add this information to these slabs. If I look at the properties of these balcony slabs, I can see that there is information about the location, the material, codification, and so on. But there are apparently no other properties aside from some planning data. So no properties assigned. So there's, for example, I can see no IFC slab common property set, which would be a typical property set you would assign to this kind of object. So let's actually add that. So I can use either IFC defined property sets. What you see right now is a filtered view of all the property sets that would be applicable for my current selection, which is for slabs. So let's search for the slab common property set. And let's add the ones we're interested in. For instance, the fire rating is external and load bearing. I can already add some values as well. So these slabs are external and they are load bearing. And let's save that. So now I've now added these three properties to these slabs and added a value as well. So I can now indeed see these values here, which should also have updated my browse panel. So now indeed these slabs are no longer visible under the non-load bearing point here. Same goes for fire rating and for is external and other properties as well. So for instance, let's take these balconies here. And let's add some custom properties as well. So again, we can use IFC defined properties, or we can use custom properties. I've already defined them beforehand, but you can of course create your own sets. I will just use this predefined one here, and let's say I want to add a phasing information about to these balconies, just like this. All right, so I think we've done the entire list of specifications according to this IDM. So I hope Dieter is happy with my work. I can now simply export an IFC file back from this model, and it should contain all the changes that I've added over the past 20 minutes. Dieter, anything to add?
No, Jacob, thank you very much. Well, I think it was good to see that my first BIM project is better than to throw away, and I can share it with my structural engineer. So thank you for the help.
Okay, thank you.
Is there any questions?
ask a quick one. Is your tool already added to the list of tools that support Open BIM standards on our website? Do you know there is this list?
Yes, and we're on it, but not
Just
with the
wanted to
correct
mention to
name,
everyone
I
that we have
think.
this list.
Yeah. Yeah.
Thanks. Any other question?
Could I have a question to the previous talk? If we have time, I would like to ask a question to the ETIM presentation and or product related, and that concerns the ongoing work with product passports and so. How do you relate the work that is done by ETIM to that work? How is it related?
Thank you for that question, and thank you for the wonderful presentations after mine as well. Well, we define technical products with specific attributes and
previous model. So every change that is made, like Jakob did now, it's a session, and you can publish those changes, and it will become a new version. It goes automatically, and it will keep all the versions from the previous sessions in a register, and you can always roll back to an older one, like the first one or the previous one.
The information feedback to the IFC models.
Yes.
So it cannot be reflected to the original BIM model, for example, Revit or ArchiCAD.
Yes, yes. Well, yes, but that's also for, that's all, it's possible that you have your modeling tools like Revit or ArchiCAD or any other, and that you modify the model there, and then you push that information or by a Revit file or from a new IFC export to Conic, and it will merge the changes. So it's, yeah, it's foreseen to coordinate all those changes from different platforms into one platform, in the Conic platform.
Okay, thank you.
Maybe just to be complete, if there's some conflicts of some changes done in the two different systems, and there's also a check to do some conflict handling. So like if there's, for example, a door moving to the left in one system and then someone else moves the door to the right, okay, that's a conflict. And then there is a procedure for conflict handling so that after the information is merged, there's only one single source of truth.
Corresponding to this question, so IFC or is a native BIM model modification it's very interesting situations, and I'm not quite sure 100 sure it's a Yoshiyuki's demonstrations. He demonstrated to one opportunity to it's kind of a bSDD can be utilized for BIM authoring phase to import some kind of information requirements from bSDD by using a plugin, for example, Revit or ArchiCAD. This kind of plugin can communicate with bSDD. And so when you're modeling your own native model, bSDD still can help your data interoperabilities and the cleanness. So please the contact to Yoshiyuki to much more detail about how to use the plugin with bSDD for that. Yeah. That's my comment. Thank you.
Thank you. Any other questions? Okay, give it back to you. Do you want to close? Or?
No, you can close.
Thank you so much for those presentations then.